So far, we've been allocating the cost of equipment and buildings and calling it depreciation. Now we point to the exact same idea at a different kind of asset, natural resources. And just by changing the type of asset, the name changes to depletion instead of depreciation. Oil reserves, coal mines, gravel pits, tracts of timber, these types of things get used up, physically consumed as we extract them. Let's see how we allocate their cost. A natural resource is an asset that we literally consume. An oil field doesn't wear out from use the way a truck does. It gets physically depleted, barrel by barrel, until it's gone. Because the value comes out in units, barrels, tons, board feet, natural resources are almost always depleted using an activity-based method. The same as units of production approach we just learned for depreciation. That's the key connection. Depletion is units of production allocation applied to a resource. First, we need the depletion base, the total cost we're going to allocate. It has more components than a typical equipment purchase, so let's build it. We start with acquisition cost, what we paid for the rights to the resource. Then we add exploration and development costs needed to prepare the resource for extraction, like drilling, tunneling, and the like. Then we add any restoration obligation, so an estimated cost to return the land to its required condition once we're done. And then we subtract the residual value of the land after extraction. Acquisition plus development plus restoration minus residual value gives us the depletion base. Now, from here, it's just units of production. We take the depletion base and divide it by the total estimated units that the resource is expected to yield. That gives us a depletion rate per unit. Then we multiply by the number of units we actually extract this period. So let's look at one. Suppose a mining company pays $1 million for a mineral deposit, spends $200,000 on development, and expects no meaningful residual value. They estimate that the deposit holds 500,000 tons. The depletion base is 1.2 million, and dividing by 500,000 tons gives us a depletion rate of $2.40 per ton. If we extract 80,000 tons this year, depletion for the year is 80,000 times $2.40, which is 192,000. Now here's one subtle but important difference from depreciation. When you depreciate office equipment, the expense usually goes straight to the income statement, but when you deplete a natural resource, you've actually produced inventory. Those 80,000 tons of ore are sitting in a stockpile somewhere. So depletion first attaches to that inventory as a product cost. It doesn't yet become an expense, cost of goods sold, until the inventory is actually sold. If the company extracted 80,000 tons but only sold 60, then only the depletion attached to those 60,000 tons hits the income statement this year as cost of goods sold. The rest stays on the balance sheet and the inventory account, another deferred expense. The allocation concept is identical. It just flows through inventory on its way to expense. So depletion is simply units of production allocation applied to a natural resource that we physically consume. The depletion base is acquisition costs plus development plus restoration costs minus residual. Then we divide that base by total estimated units to get a per unit rate, and then multiply by units extracted. And unlike most depreciation, depletion typically lands in inventory first and only becomes cost of goods sold when the resource is sold. One more asset type to go, the intangibles, where allocation takes its final name, amortization.